Guys, real quickly, in the past when we've solved equations with variables on two sides, maybe something like 2x, whoops, maybe something to the effect of 2x plus 4 equals maybe, let's see, how about 4x minus 20? Okay. Just remind me process on this again. We're kind of going away from two variables, two equations, two variables. We're kind of going back to that one variable, one equation type setting here. If I was solving an equation with variables on both sides, how would that look algebraically? What would you do first? Chelsea, you got it? Say it one more time. Okay, I can subtract 2x. All right, so let's do that. Let's see what happens. I could have also subtracted 4x as long as I get the variables to one side. Doesn't make any difference. Okay, so in this right here then, 2x's would cancel, right? You got 4 on the left, and on the right, what did you have? 2x minus 20? All agree so far? All right, so what are you going to add to both sides then? Add 20. So this would become 24 equals 2x. So what's that make your x value in this? Is that door locked back there, Chelsea? Yeah. Will you do me a favor quickly? I'm going to use the orange one and unlock that building. Got to do it on the back side. All right. So what did we say our solution was here? 12. All right. Guys, here's how I want to start looking at stuff graphically. Okay, here's how I want to start looking at stuff graphically. We'll find out next time someone wants in, right? Thank you very much. Okay. So here in your notes, guys, if I would say, starting with example 1, solve equations by graphing right here. We want to understand how to do this by graphing. Now, in the last or in the beginning part of chapter 5, we had systems of equations. We were putting in y equals one equation and y equals another, right? The way you handle stuff with equations where you have a variable on both sides, it's the same variable as this. You kind of set this up as a, this is kind of your left-hand part of the equation, and this is kind of your right-hand part of your equation, okay? Let's just go through this real quickly and see what we get algebraically. Could I subtract x from both sides in this first? Would that be okay to do? So I'm going to do that quickly. Let's subtract x here on both sides. And what I end up with, gang, is 1x plus 3 equals 2. So then very simply, you would subtract 3, wouldn't you? All right. So when you subtract 3, you've got x equal negative 1. All right. Everybody okay with that? So graphically, what does this look like? Well, here's what I want you to do. Okay. You have a left side of the equation and a right side of the equation. Somebody tell me what that left side was again. What was the whole 2x plus 3? So what you're going to do in decimals is you're going to come in here and you're going to type 2x plus 3. By the way, 2x plus 3 is in slope-intercept form, isn't it? What's the y-intercept for 2x plus 3? And what's its slope? 2. So if I had to graph this, and I'm telling you to graph it this way, if I had to graph this 2x plus 3 like this, you would have your y-intercept right here at 3. And then you're going to have a rise over run 2 over 1, right? All agree? Now what's our x value in this solution that we've already shown algebraically? What is it again? Negative 1. All right, what was the second part of the equation? What was the right side? X plus 2. You guys agree that the intercept on that is 2? Y-intercept would be 2, right? And then how about a slope value for that? 1, right? Okay, so if I type this in, if we go x plus, what was it, x plus 2 again? X plus 2, okay? All right. Guys, is there a point of intersection here between those two lines? Right here, isn't it? What's that point? Negative 1. That ordered pair is written as x comma y. However, when we started the equation, what variable was the only variable that existed in the problem? An x. This is giving me an x comma y coordinate right here, isn't it? Well, what is the x value for that coordinate? -1, isn't it? Isn't that matching what we had there? So what you're going to do is you're going to put the left side in the top field, the right side in the second field, and at which of these values am I looking for my point of intersection? The x value or the y value? Well, what was our solution again? It was the x value, -1, right? Okay. So let's take a look at this second one real quickly. Let's see. Where in the world did I set that down? I do this all the time, guys. I cannot seem to break this habit. It's a New Year's resolution. There it is. There it is. I should just like wear this around my neck, shouldn't I? I'd probably take it off and lose it. That's just it. All right. Let's try the second one in. Now the second one here is going to start involving absolute value. Okay? Absolute value. Is that door locked? Okay.
The following students please come to the office: Allie Hampson, Seth Hannes, Morgan Harrigan, Brianna Harvey, Sophie Haynes, Bobby Hilmer, Dakota Hora, Macy McLaughlin, Ryan Miller, Keith Newbern, Cole Pearson, Trey Redmond, Brady Rempe, Peyton Sash, Trayton Slater, Dylan Steck, Isaiah Vaughn, Josie Weber, Brody West.
Okay, next one here, absolute value stuff. Now again, guys, we have decimals to do this. We have decimals to do this. Notice, guys, in this situation, how many variables are in the equation? Are we using 2 variables like we have in the past, or are we back to 1? Back to 1, just the x's, right? So how do you plug this into decimals? Well, let's check it out. You guys tell me what the left side and the right side are. So in field 1 up here, what do you want to put in up there? For example 2, what do you want to put in field 1? Absolute value of x plus 3, right? Okay. Where is your absolute value button? Okay, it's right down here. It says absolute value of a. So we're going to type that in there. And what's inside my bars? X plus 3. Okay. Should. Have your keyboard up? Okay, got it? Okay. Then, this is a graph you get for an absolute value function. What's the right side looking like, kiddos? So make sure I do absolute value and 3x plus how much? Okay, graphically, that's what it looked like. Guys, how many points of intersection for the green graph and the purple graph? 2. So how many x values to this? 2 of them. All right. Real quickly, right here, what's one solution going to be? -1. How about my second solution? 1, right? Going to be 1. Pretty simple, isn't it? Okay, so I know a couple people said, boy, I didn't know how to put that stuff in. Are we understanding how to do that now? Left side of the equation up top, right side on the bottom, you're on your way. So by the graph right here, by the graph, what are my solutions again for example 2? What did we get for solutions? Or x could also equal, what was the other value? Very good. Very good. Okay with that? I think these might be the shortest notes in the history of Mr. Parsons' math class. Questions on the front side?
It's a new world record.
It is.
Yep.
All right, are we ready for page 2 here? Second side? All right, so let's run with this. Guys, we've looked at examples like this before. So again, but we want to get used to this. How do you do this graphically? What's this look like graphically? Example 3 says your family needs to rent a car for a week while on vacation. It says company B charges $3 per mile. Holy cow, $3 per mile. Plus a flat fee of $150 per week. Company A is going to charge you $4 per mile and a flat fee of $75 per week. After how many miles are the total costs the same for company A and company B? All right, which company is cheaper to start with? Kind of mixed it up on you a little bit. Company B. Let's just talk about Company B right here. They're going to charge you a flat fee of how much? Because it's out of order, right? Yeah. All right. How much is Company B charging, no matter what? $150. So if I get the car, and maybe we just sleep in the car at the car rental place and don't drive it anywhere, we're going to pay $150 for the whole week, right? Okay, that'd be kind of weird. How much are you being charged per mile? $3, right? So we need to add something to that. Do you know how many miles we're going to end up driving this thing? We don't have a clue. So what do you want to add to this in terms of an expression for $3 per hour? Plus $3 per hour. I'm just going to go plus 3x. Is that okay? You guys okay with that? Yeah. X is going to represent the number of miles you drive your car. So every mile you drive the car, you add how much money? X miles at $3 per mile, right? All right, well then, Company A. What's Company A's flat fee? $75. And Company A, how much are we charging per mile there, guys? $4. So we're going to add what expression to the $75 flat fee? You bet, 4x. Now, just like we did in the last two examples, we had two expressions equal to each other that involved an x on the left side and an x on the right side. Right here, the question's coming at you and saying, after how many miles will the total cost for the same be the same, I should say. After how many miles will the total cost the same? What are you going to do with this expression for a cost on B and a cost on A? What are you going to do with each other? We're going to put them in decimals. We want to know after how many miles are they the same. So what we're really trying to find here is solve for x when you have the following.
The following students please come to the office. Dylan Steck,
plus 3x.
Josie Weber,
Whoops.
Callie Brandanger, Bailey Bruce, Jackson Buns, Ryan Conley, Tanner Cummings, Lauren Ewalt, Kira Pfeifferlich, Katie Freeland, Houston Freeman, Caitlin Helgeson, and Carter Hennessy.
Solve for x when these two expressions are equal. They want to know after how many miles are they going to be equal. So what value of x is going to make those two expressions for cost equal? All right, so let's toss it in here quickly. You guys have that written down at least? All right, so back in here, guys, left-hand side of the equation. What do we put in there? 150 plus 3x. So let's do that. 150 plus 3x. Next one. Okay, anything showing up on my graph? So this is probably the time where we have to zoom out a bit, see what's going on here. Nothing. I see some lines coming. Uh-oh. 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 Whoa. There it is. I see my point finally. Guys, which of those two values do you want as an answer or a solution to your question? You want the x value, which is going to be what? 75 miles here. Okay? 75 miles. So back to this right here, we'll say the x value is 75. So to wrap this up, this simply means that at 75 miles, the cost for company A and B will be the what? I don't know, guys. This might be the easiest section we've had all year. My opinion. It's up there, isn't it? Yeah. It's up there. Okay.
Did you guys already do
Not yet, we haven't done anything yet. Oh my gosh, I didn't even think about that. I guess board of thought, if you don't know the answer in that class, take a guess. I know what I would guess. All right, I'm gonna stop this here.